Hi, this is Mr. Ward, and I'm going to do a third video on solving systems by substitution. And this time I'm going to, last video I worked with one where there was no solution, where you went through the whole process of substitution and you ended up with a really nonsensical answer of -8 equals 64. So you get that, there's definitely no solution. So I've done a different one, and once again, if we do 8x minus 4y equals 64. I used that same one. Then I did 2x plus y equals -16. And again, it's the same slope, negative of a over b. So a over b is 8 over -4, which is -2. The negative of that is 2. Again, -2 over 1 is -2. And you get the opposite of that. That becomes a positive 2 slope. So they both have the same slope. So let's see what happens when we resolve the system using substitution. Again, I don't have any variables isolated, but this y is the easy one to isolate, so let's pick on it. So I'm going to go and copy that so I have a place to work with. To isolate it, I'm going to add 2x to both sides. So plus 2x. So now I have y equals 2x minus 16. So I added 2x to both sides. Okay, so once I've done that, I can take 2x plus 16 and substitute it in for y in this equation. Okay, so I'll copy that in here, do a few returns to get some space, and I'm going to take this expression for y, 2x minus 16, and I'm going to replace y with that. And now I've got this. So 8x, I'll start simplifying, 8x minus now 8x, notice we're going to get rid of 8x, and then -4 times -16 is going to be plus 64 equals 64, and now 8x minus 8x is just 0. I'm left with 64 equals 64, which could easily become 0 equals 0 by subtracting 64 from both sides. I've gotten something that is simply true. And what that means is I have infinite solutions. I have infinite solutions because it doesn't matter what x and y combos I put in here. As long as they're x and y combos that work for this line, there will be x and y combos that work for this line. There will be an infinite number of x-y combos that work for each line because each line is the same line. We already knew they had the same slope. Let's double check and see other tools we have. We can find the y-intercept by doing 64 divided by -4. Because the y-intercept, we don't care about the 8x, it goes away. So 64 divided by -4 is -16. Here I'm going to be not paying any attention to the -2x because x is 0 when you're the y-intercept. -16 divided by the 1 that is times y is -16. We end up with a y-intercept of -16 for both equations and a slope of 2 for both equations. Same slope, same y-intercept, same line. I'm going to test this out for the x-intercepts as well. If I ignore the y component by turning y into 0, I'm on the x-axis. So I can get the x-intercept. So 8x equals 64. 64 divided by 8 is 8. So that's my x-intercept. For the second equation, I take the y and turn it into 0. So I'm left with -2x equals -16. Divide -16 by -2. Again, I get x equals 8. So again, I have an x-intercept of 8. So both equations have the same x-intercept, same y-intercept, same slope. They are the same line. They are on top of each other with an infinite set of xy points that make that line true. I hope that's been helpful.